All right, we're going to go ahead and graph a quadratic function. And where before we just kind of wrote an equation from a graph, or we were able to write an equation from words given to us, this time we're going to physically graph what we're told. So I'm going to show you a way of using a table that'll kind of help you with this. So our first question says f of x is equal to 3x squared. So in my table, I'm just going to use 3 points. I'm going to use -1, 0, and 1. And those are going to be my x's. And inside, I'm going to write the function rule. And then I'm going to have f of x, which is also y. So if I take 3 and I multiply it by -1, which is x in this case, and I square that, I've got -1 squared, which is the same as saying -1 times -1, which is +1, and +1 times 3 is 3. Then I've got 3 times 0 squared, 0 squared is 0, times 3 is still 0, and then 3 times 1 squared, 1 times 1, which is 1 squared, is 1 times 2 is 3. So over here I'm going to come and I'm going to start plotting at the vertex as the direction straight. So I'm going to point there at 0, 0, and I know that 0, 0 is my vertex because if I look on the right hand side, this is the lowest point in the table. And we talked about minimums and we talked about vertex, so we're using that same reasoning while we're graphing. So then I'm going to go, I've plotted 0, 0, I'm going to go to the left 1 and up 3 and place my dot. Now I know that my quadratic should face up because my number, or my a, is positive. So let's make a note. When a is positive, graph or quadratic should smile. Okay, so this would be the answer to this one. Let's go ahead and look at the next one. We have f of x is equal to -x squared. So again, I'm going to pick 3 points. I'm going to pick -1, 0, and 1. And I've got -x squared there. And then this is going to be my output. Forgot to leave myself room there. So -1, so we're going to do negative, and then x squared is -1 squared. So be real careful about this. This negative is out here, but x is -1 in this case. So -1 squared is -1 times -1, which is +1. +1 times -1 is -1. Then we've got -0 squared. Well, we can't have a -0 squared, and 0 times any number is just 0. Then we've got -1 squared, because x in this case is 1. So 1 squared is 1 times -1 is -1. So we're going to plot our vertex, which is 0, 0. And we're going to go 1 to the left and down 1. So notice when a is negative, the graph frowns. He's sad. All right, let's submit that. Okay, so our next one, this was 1, this was 2. Our next one says f of x is equal to -x squared minus 8. So what we know is that the graph has been reflected, so it's going to fold down and it's moved down 8. And we're just going to prove that. So we're going to have x, And we're going to have our function rule and then f of x. Now, what I notice here is there's no movement left or right. So I can still use these points. We just have to be really careful that they're fit on the graph. So I'm going to use -1, 0, and 1. So I've got negative, and x is -1 squared minus 8. So -1 squared is 1 times -1 is -1, and -1 minus 8 is -9. Then we've got 0 squared minus 8. So 0 squared is 0 times -1 is still 0 minus 8 is -8. And then let's go ahead and do negative. And then we've got 1 squared minus 8. So 1 squared is 1. And then we multiply it by -1, which gives me -1, and -1 minus 8 is -9. So again, we're going to plot our vertex, and we know that 0, -8 is our vertex because, again, it is the lowest point in the graph. So we've got 0, -8. Now, again, this quadratic is reflected downward. So what I'm going to do is I'm going to come over 1 to the left and point it down. Now, if you follow your points, you should be okay. Let's go ahead and look at number 4. Scoot this over a bit. We've got 2x plus 4 squared. Now, automatically, what I can tell you is that there is a left or right movement because I have my parentheses. And I can tell you that it's the function itself moved to the left 4. Now, when we're using the table to help us, lost my train of thought. When we're using the table to help us to pick out points, I'm going to tell you something. It's easiest to make sure that you pick points or values, or values that will make the inside of the parentheses, yes, maybe I should move this over so you can see, the inside of the parentheses equal 0. And then you're going to pick points to the left and to the right of that. Let me show you what I mean. So let's get rid of this. And we're going to put x, then the function rule, 2x plus 4 squared, and then we're going to have our f of x, or y. Now, to make this 0, what I know x would have to be is -4. So I'm going to put -4 right here in the middle because I know this is going to probably be my vertex. I'm going to pick a point to the left and to the right of that. So I'm going to pick -5 and I'm going to pick -3. And the reason I'm doing that is if we say we picked 0, by the time we got through with it, the number would be so large we wouldn't be able to fit it on this graph. So that's why I'm choosing to use points that make the inside of the parentheses 0. So we've got 2 multiplied by -5 plus 4 squared. So -5 plus 4 is -1. And -1 squared is +1. And 1 times 2 is 2. Then we've got 2 we got negative 4 plus 4 squared. Well, negative 4 plus 4 is 0. 0 squared is 0. And 2 times 0 is 0. Now, let's do negative 3 plus 4 squared. Well, negative 3 plus 4 is 1. 1 squared is 1. And 1 times 2 is 2. So now we have our points. So negative 4, 0 is the vertex. And that makes perfect sense because up here, there's no plus or minus number saying that the quadratic moved up or down. It just moved left. And then let's plot the number to the left, which is negative 5, and up 2. And I know this is facing the right direction because this is a positive number. Now we're going to do the next one. All right, on this one, we've got some left-right movement and some up-down movement of the quadratic. So we'll just take this a little bit at a time. Again, we've got movement here. So let's think about, if this were the parent function, what would I have to do to get back to 0? I'd have to have a positive 6. So I'm going to make positive 6 my first point so that I can get the vertex, and then I'm going to pick a point to the left and the right, so 5 and 7. So we have 4, and then x is 5 minus 6 squared plus 3. So 5 minus 6 is negative 1. Negative 1 squared is 1. 1 times 4 is 4. 4 plus 3 is 7. Then we've got 4. 6 minus 6 squared plus 3. Well, 6 minus 6 is 0. 0 squared is 0. 0 times 4 is 0. And 0 plus 3 is 3. Then we've got 7 minus 6 squared plus 3. 7 minus 6 is 1. 1 squared is 1. 1 times 4 is 4. Add 3 is 7. So our vertex is 6, 3. We're going to go over 6 and up 3. And that makes sense because in vertex form, which we haven't gotten to yet, vertex form would be whatever this number is and whatever the outside number is. But we'll get there. And then 7, 7, 7. As you can see, in the interest of time, I kind of skipped a level because I didn't want to make this video really long. But the only way to get really good at this is to practice it. So what I know from this is that when I get done, my quadratic should have moved 2 to the left and should have went down. So my vertex is going to be somewhere about right here. So let's mathematically prove that. I need a number that's going to make this 0. So negative 2 plus 2 makes this 0. So I'm going to do negative 2 as my vertex, pick a number to the left and right. So I'm going to pick negative 3 and negative 1. So we've got negative 4. Negative 3 plus 2 squared minus 4. Well, negative 3 plus 2 is negative 1. Negative 1 squared is positive 1. Positive 1 times negative 4 is negative 4. And negative 4 plus a negative 4 is negative 8. Then we've got negative 4, negative 2 plus 2 squared minus 4. Well, negative 2 plus 2 is 0. 0 squared is 0. 0 times negative 4 is 0. 0 minus 4 is negative 4. And then we've got negative 4. And again, we've got negative 1 plus 2 squared minus 4. So negative 1 plus 2 is positive 1. 1 squared is 1. Times negative 4 is negative 4. Negative 4 minus 4 is negative 8. So we're going to plot our vertex, which is negative 2, negative 4, which is exactly where I said it was going to be. And then I'm going to go negative 1 to negative 8. And that makes sense because I've got a negative number here. Okay, so on this one, we've got f of x is equal to 5, x minus 9 squared plus 1. So I know that this function was moved 9 to the right and up 1. So my vertex should be right here when I prove it. So I'm thinking, okay, what would make this inside 0? Well, I know that would have to be positive 9. And so I'm going to pick a number to the left, which is 8, and a number to the right, which is 10. So we've got 5, 8 minus 9 squared plus 1. Well, 8 minus 9 is negative 1. Negative 1 squared is positive 1. 1 times 5 is 5, plus 1 is 6. Then we've got 5 times 9 minus 9 squared plus 1. So 9 minus 9 squared is 0. 0 squared is 0. 0 times 5 is 0, plus 1 is 1. And then we have 5. And then 10 minus 9 squared plus 1. So 10 minus 9 is 1. 1 squared is 1. 1 times 5 is 5, plus 1 is 6. So let's go ahead. Like I said, the vertex would be here at 9, 1. And I'm going to go over to 8 and up to 6. And that would be our answer.